warm up on Monday because you guys already have enough going on this weekend. But so you have to know what a polynomial function is. And again, so you have to know if something is a polynomial function because we're going to study a couple things this year that are not polynomial functions, like rational functions, 1 over x. That's not a polynomial function. Or knowing that something that's a conic, you guys aren't going to spend much time on conics, but knowing that that's not a polynomial function, x squared plus y squared. So what is a polynomial function? Oh, another one. This is not a polynomial function, square root of x, absolute value of x. Those are not polynomial functions. They have to have real coefficients, no imaginary numbers, and they have to have whole exponents. And they're smooth and continuous. So our friend square root of x is not continuous because over here it doesn't exist. And then absolute value is not smooth. It has this jagged turning point. And let's see, a real number excludes imaginary numbers. So you cannot have the square root of -4x squared, right? That's not a real coefficient. So that causes some error. And then it says it has to have a whole number exponent. So I can't have x to the -2nd, x to the 1/4 power, right? Those are not whole number exponents. So it's basically things that you already know. Linear, quadratic, cubic. These are all polynomial functions that we're grouping together. I think you already know what standard form is, but it applies to all polynomial functions. And the degree is the highest exponent. So quadratic, x squared is the highest exponent. Cubic function, x cubed is the highest exponent. And then we're going to talk about the leading coefficient. We've already talked about it for standard form, but now we know that the leading coefficient is in front of the highest exponent term. So I just put some basic terms in here. If you haven't heard of a constant function before, it's just a horizontal line like y equals 7. I think you know that this is a linear function, y equals mx plus b. Quadratic, we just studied pretty in depth. We've already looked at the cubic function. This is called quartic, 4th degree. We've talked about that a little bit with factoring. Anything higher, you just call it like 5th degree, 6th degree, 7th degree. So all those terms, I'm kind of running under the assumption that you've kind of reviewed them or you've heard them before. And then you should know these terms too, a monomial versus a binomial versus a trinomial. So you can name it by its degree and how many terms it has. So this 2x is called a linear monomial. This linear function here is called a linear binomial. This one would be called a quadratic, and there's 3 terms, so it's a trinomial. And the only reason I'm throwing this part on here is for those of you taking the SAT, because I'm not going to throw terms that have like y's in them. These are not polynomials, but I want you to know how to name them in case you see it on the SAT. So it says find the degree of the following monomials. If you have a couple terms in there, you find the total degree of all the terms. So this is just 3rd degree because y cubed, but this weird looking thing is considered 4th degree because you have x to the 1st y cubed. So this would be 5th degree, x squared y cubed. You can add them together. But I'm not going to be asking you this on our test because these are all non-polynomials. I'm focusing on polynomials in this unit, but I kind of wanted you to know in case those ever pop up on an assessment, not in this class, but outside of this class. All right, so there's a lot of terms on there to kind of know and refamiliarize yourself with if you aren't familiar with them. Here's something that multiplicity might be a little bit new for you. Might not have learned it in Algebra 2. You should know that a 0 can also be called an x-intercept, a solution, or a root. And if the polynomial can be factored, the zeros basically, right, are what makes it equal 0. I put in bold kind of a new rule for you that you might not know. A polynomial can have at maximum the same number of zeros as its degree. So a quadratic function, right, our parabola, it could have 2x-intercepts. It could have 1x-intercept. You don't have to draw this, but it could have 0x-intercepts. So it's telling you the maximum number of zeros is the same as its degree. So that you're going to need to know, that little bold rule right there. And this one just says, hey, let's do what we just did on our quiz. Let's factor and find the zeros and then sketch the graph to see how many zeros it has. So how would I factor this quadratic? Did you get that okay on your quiz? It'd be x what? Factors of negative 12 that add up to 4. What would you say? What? 6 and 2. I want my 6 to be positive and my 2 to be negative, right? So what are the two x-intercepts? So my x-intercepts are at negative 6 and at positive 2. So I actually do have two x-intercepts this time, right? Concave up goes through at 6 and, or negative 6 and 2. All right, so multiplicity is something that you may or may not have seen in Algebra 2, depending on when you took the course. In factored form, the multiplicity of a zero is the degree of the factor in which the root appears. So up here, x plus 6 and x minus 2, they both have a multiplicity of 1 because they're both to the first power. But in this one down here, something else is happening. X times x minus 5 squared. So what are my two zeros? 0 and 5. So it says 0 has a multiplicity of 1 because that's x to the first power, but 5 has a multiplicity of 2 because x minus 5 is being squared. So I want to show you what this graph looks like on a graphing calculator. X times x minus 5 squared. All right, so it's a cubic function. I can't quite see the top of it. So it kind of goes up here, bends around, comes down. What's happening at the 5 on the x-axis? It's bouncing off the axis. But what's happening at 0? It's actually cutting through the axis at that point. So based on the multiplicity, you're going to be able to tell if the graph bounces off the x-axis or cuts through the x-axis. So at 5, the graph was bouncing off, but at 0, it was cutting through. So I want you to write down bounce off. Oops, can't see this. Oops. So bounce off or cut through. So it cuts through at 0 and it bounces off at 5 based on the multiplicity. So I'm going to write m equals 1, m equals 2. Think about even as like quadratic, right? This is kind of like a quadratic bouncing off the graph right there. And then this is like a linear function cutting through the x-axis. And then here's the rule about multiplicity. So this is like a resource page about all things polynomials that we're going to eventually pull out. But this is our resource to do some guided practice, because I don't know what you remember or don't remember. So it says if you have an odd multiplicity, like multiplicity of 1, the graph will cross the x-axis. If you have even multiplicity, like x minus 5 squared, that's an even power, the graph will touch the x-axis but not cross through. So bounce off, cut through. I know this is a lot of rules. This is like your little Bible, and then you're going to do some practice. Here you go. So what about end behavior? I know we looked at this in Algebra 2. And what I'm talking about end behavior is like, what is this end of the graph doing? It's going up. What's this end of the graph doing? It's going down. Do you remember talking about that in Algebra 2, perhaps? Anyone remember what the rules are? If the leading coefficient is positive, what's the right side of the graph do? Positive, so up. If the leading coefficient is negative, the right side goes down. You always do the right first, step 1. You can't read that though. Step 1. And then step 2, you look at the left side. Remember, if like it's a quadratic, they would go in the same direction, like a U shape. And if it's odd, they go opposite directions. Odd, opposite. Both start with the letter O. In Algebra 2, we did a little dance with our hands, like, oh, it's x squared. They both go up. And then it's like x cubed. They go one like this, like we did shapes of the graph. Maybe you didn't do that, but. All right, and then the last rule, and then all the rest is some guided practice. So I was going to like lead you through the first in each section today, and we'll start with this on Monday. Turning points. A polynomial with degree n has at most n minus 1 turning points. Think about your friend, the linear function. How many turning points does a linear function have? 0. How many turning points does a quadratic have? 1. So it's 1 less than the degree. So if it's a 10th degree function, it could have 9 turning points. Chances are it's not going to have 9. Oops, what happened to my picture? I don't know why it's so light. So it could have 9 turning points. And this one, if this has a degree of 3, a cubic function, oops, could have 2 turning points. So a maximum of 2 turning points.